Hey, hello. Welcome back to our channel Physical Academy. This is IISERS and I am an educator on this channel for organic chemistry. So, in this lecture, we are going to study about the aromaticity. We have already taken one lecture of on this topic, aromaticity. In the last lecture, we have discussed about the aromatic compounds, anti-aromatic compounds, and non-aromatic compounds. We have uh, uh, we have solved some questions also in the last class. So let's proceed with the next topic, quasi aromaticity compound. Okay, so this is the last class of this aromaticity topic. So this we have already talked the conditions of aromaticity for Huckel's rules, and these are the examples we have already discussed. This is anti-aromaticity compound, and this is the condition. Are the examples we have already done. So there's some good questions which will ask in your examination. So some exceptions also. This type of questions are exception. 8 membering we have discussed. This 10 membering also discussed. So now we are going to talk about the quasi aromaticity. Okay. So this is also important. Um, Very basic question will ask from this topic, quasi aromaticity in MSc NTS examination especially. You can see in the previous year question PYQ of the DU and BHU. Okay, so let's start. But before starting, I want to say that if you are new here on this channel, please subscribe. And if you like the content, you like the lectures, so please share with your friends so that they also get the benefit of this channel, because this channel is totally free and providing you the best content from the best educators from different side of India. So if you want to prepare IITJAM and MSc examination, if you want to go in the for IIT for masters, so please uh, uh, follow the lectures, and if you like, then subscribe and share. And okay, so let's start with the our topic, quasi aromaticity. uh, what it say, quasi aromaticity is just example a double bond b. If one compound we have a double bond b, this is the neutral compound. Okay, this is neutral compound. But if we just break the bond, one bond break, minus charge, this is plus charge. Okay, so this create this type this create a partial positive charge and partial negative charge on both the atoms. So this is due to, for this to happen, this is called as quasi aromaticity. And now we will look the example. Okay, quasi aromaticity. Okay, so why we called as aromaticity, why we called as quasi aromaticity. Okay, so and also one thing is very important here, that that will be asked in the question for your exam. What is the application of quasi aromaticity? The first application is if any one compound have a quasi aromaticity, then it's a high dipole moment. It have the high dipole moment. This is very important. Sometimes they not ask about the quasi aromaticity. They ask, they give the compounds and tell you to find out the whose dipole moment is the maximum. So you have to uh, see the compound which have quasi aromaticity. If a compound has quasi aromaticity, then it have high dipole moment among all the given options. Okay, so this is important. Second point is polar form. Polar form, more stable, more stable, more stable. It means this polar form is more stable than this. Okay, now we are talking about the types of quasi aromaticity. Types of quasi aromaticity. Types of quasi aromaticity. Three types of quasi aromaticity. First is cyclic, hydrocarbon, carbon. Cyclic hydrocarbon. Second, cyclic carbonyl. And the last is azulene, azulene system. This is also important, azulene system. Okay, so we will talk about these three types of quasi aromaticity in this lecture. So let's start with the cyclic hydrocarbons. Okay, like this. This is your compound, okay, and you have to check this bond. This bond will polarize, okay. This bond will polarize and create a positive and negative charge here. So now we can see that let's take this negative charge and this positive charge, sorry, this positive charge and this negative charge. Why we take this? Because if positive charge come on this carbon, this become aromatic, this become aromatic, this become aromatic. And what this, the 2 2 4 6 6, this also become aromatic, this also become aromatic, because 6 pi electron, 6 pi electron means 3 pi bond, or 3 pi bond means aromatic. So both the rings are aromatic, so overall compound is aromatic. So highly stable compound, okay. This is called quasi aromaticity, this is called quasi aromaticity, which will create by the polarization, okay. This is called quasi aromaticity. But sometime take another example in which not aromatic, just take example. Yeah, okay, this is your example. So what can we say? This is negative charge, this is negative charge, this is positive charge. Doesn't matter which ring has contain positive negative, because both become same, okay. If we take positive here and negative here, it's both become same, I think, okay. So doesn't matter. Let's this is negative charge. So you can see here 2 to 4 4 pi electron, it means it is the foreign electron rule follow. It's follow the rule of foreign pi electron, so it is anti-aromatic, it is anti-aromatic compound, anti-aromatic ring, and this is aromatic ring. So if this type of compound is here with which contain both anti-aromatic and aromatic compound, then it will called as non-aromatic compound, it will call as non-aromatic compound. It means this is non-aromatic compound, okay. So you can write this, important, this is important. If both are aromatic, then it's aromatic. If one is aromatic and other is anti-aromatic, then you can say this is called as non-aromatic, okay. So this is a cyclic hydrocarbon quasi aromaticity, and this have very high dipole moment. You have to learn, you have to remember that this have very high dipole moment. This is the question will be asked, okay. Not directly that which contain quasi aromaticity, they always ask which has the maximum dipole moment, okay. This type of question will be asked, okay. Now we are talking about the concept of bond rotation, okay. Concept of bond rotation, sometimes they ask also which have more bond rotation, okay. Which can easily rotate, okay. With the help of quasi aromaticity, we can identify which have the uh, less bond rotation or more bond rotation. So this is also helpful to determine the bond rotation, okay. So let's take example, very simple. uh, this compound, we have already taken this in the last slide. So this will come like this become both aromatic, yeah, okay. This become both aromatic. If we this done, this become both aromatic compound. This is also aromatic, and this is also aromatic. So it become aromatic compound, the whole compound is aromatic compound. So So it is very easy to rotate because this single bond, single bond is easily rotation, is, is easily rotate, okay, with the axis. So this has easily rotation take place because both are aromatic compound, aromatic ring. So this bond this bond will not stay for the long time because it will form both aromatic ring and it will form aromatic compound. So this is more stable than this. So that's why this pi bond will not stay for the long time. So it will become form this type of bond, single bond, and it get easily rotation. Okay, so this is the concept of bond rotation. So sometime when anti-aromatic and aromatic compound come, then it become non-aromatic. Then we can say that a rotation is not easily possible because the compound become non-aromatic. So compound does not want to lose their pi bond. Okay, so this is the reason. Okay, so now we will discuss about in-cyclic carbonyl compound. In-cyclic carbonyl compound, the second type, cyclic carbonyl compound. Okay, it is very easy, this type. So this is the highly electronegative atom, so oxygen contain minus charge and this contain positive charge. This is aromatic compound. Okay, so highly stable, a stable form. This is highly stable form from this. Okay, so let's take another example. Again minus charge plus charge, but now in the this time this become positive and this is oxygen has negative charge. This become anti-aromatic. So we can say this is less stable than this. The first, second, which is more stable? First is more stable than second because this is anti-aromatic. Anti-aromatic compound is very less stable. Okay, again what is the bond rotation, rate of bond rotation? You can see this has less bond rotation because this will less stable. So this will not going to stay for a long time, but this will going to stay for a long time. That's why this bond will not rotate easily. So because this double bond is not going to break because this is more a stable compound. But in this case, you can say that this is more stable first or second is more stable than first because it is aromatic. That's why if this is aromatic, then it is very easier to break this bond. It is very easy to break this bond because this will go into a stable compound, forming a stable compound. That's why it is very easy to rotate. So this is the concept about the rotation and the high dipole moment of quasi aromaticity. Now we are talking about the azoline. Azoline. So this compound is called as azoline, a specific compound. Five-member ring, and this is for seven-member ring. 1 2 3 4 5 6 7 7-member ring. Okay, yeah, this is aromatic compound, highly stable, and high dipole moment. Always high dipole moment. Okay, high dipole moment. Now this form quasi aromaticity like this. This will form negative charge and positive charge. This negative and this is positive. Okay, 2 to 4, 4 means 4 and 6. So this is aromatic, and this is also aromatic because 6. So highly stable, that's why this compound is highly stable. Okay, so let's talk about the this is the last for aromaticity. We have already discussed all the things in the aromaticity, so this much is enough for this lecture. We will discuss about some questions in the next lecture of IITJAM and MSc entrance examination. Okay, so last, if you are new here, please subscribe and share this to your friends so that they also get the benefit. And thank you. Have a good day.